Hello students. So today we are going to discuss application of derivatives. Now application of derivatives is the last topic of your calculus 1, that is your unit 2. After finishing this topic we can proceed to the unit 3, that is calculus 2. So basically in this application derivative we will going to study total cost, marginal cost, total revenue, marginal revenue, and for them there are some formulas. So let us first discuss about the formulas of total cost and marginal cost. Okay, so these are the formula for total cost and marginal cost. Let us explain this. Total cost is always denoted by C. Now the output. Now there are two notation for output that will depend on your question. If question gives output as X, you will treat whole question as X. Or if output is provided by Q, then you have to treat it by as a Q. Now suppose your output is given as X, that means your total cost, that is C, will represent a function of X. Suppose C equals to X cube plus X square plus X plus 1, like that. Or if output is represented as Q, then your C will be a function of Q, that is Q cube plus 2Q plus 1, like that, in terms of Q. So this is about the total cost notation X and output notation X or Q. Now these two are the main formula. What is the formula? Average cost. Average cost is equals to total cost by output. Now what will be in the question part, they can ask for your find the average cost. Then we know the total cost C, we know the output C, output X, so I'm using here X. So you just put in the formula that our average cost equals to C by X. Or another thing can be asked. Suppose you know your average cost, so and also you know your output, and the question demands for finding total cost. That can be also happen, that you know your average cost, you know your output, and question demands for total cost. That means from here the formula of average cost is C by X, and the question demand for total cost. So what will we can write? C equals to AC, that is average cost, into X. This can be also find from this particular formula. And the last one, that is the marginal cost, MC. Marginal cost will be the derivative of total cost with respect to the output. Now here if the output is X, then we have to differentiate with respect to X. Or if the output is Q, then we have to differentiate with respect to Q. That totally depends on the question, that in which variable the output is given. So this is the formula of total cost and marginal cost. Now we'll next discuss the different form of cost function. Okay, so different form of cost function. There are different form means, suppose your cost function is the form of like this, f of x plus k. Now where k is a constant, that means I'm talking, if suppose your function is c is like that, x cube plus x square plus x plus 1. So this part is your f of x, that is a function of x, that each of the terms is a in terms of x. That means we can say these first three terms as a function of x, and 1 is a constant, so we will denote it as a k, that is fixed number. So if the function is your like in this form, c equals to f of x plus k, where f of x is the function part and k is the constant part. So total cost equals to c equals to f of x plus k. So now first of all average cost. Now we know that average cost means total cost by output, that is c by x. C is your f of x plus k and x is your x. Now next one, average variable cost. Now remember there are two different formula here. Average variable cost, whenever the question demands for variable cost, that means you have to write f of x by x. There is no k is there, just f of x by x. Next, average fixed cost. Fixed is for constant part, so here you have to write k by x. And the last, marginal cost. Remember that marginal cost is a derivative of total cost. Marginal cost is a derivative with respect to the output of total cost. Total cost means C, so dc by dx. So this is a different form of cost function. That means if with function there is a constant term, so then what other formulas will be. Okay, so the next we will study about marginal revenue and total revenue. Okay, so the next is total revenue and marginal revenue. There are four formulas. First of all, what is revenue? Revenue is your total sale value. Basically, the sale value is called as a revenue part. So total revenue is defined as total sale value of the product. Now, first of all, total revenue, that is TR, is denoted by P into Q, where P is the price per unit of the output and Q is the quantity demand. Here the Q will treated as the output. Q you will treat as a output and P is the price. The P into Q. Next, average revenue. Same average cost like a formula, that is total revenue by quantity. That is total revenue is P into Q and quantity is your Q. Third, marginal revenue. Same as a marginal cost, that is derivative of total revenue, but remember here with respect to the quantity. What is the quantity here? Q. And the fourth one, the most important, this one is used multiple times. Net revenue, or you can say profit, equals to total revenue minus total cost. TR minus TC means total revenue minus total cost. Okay, so these are the some formulas of revenue and the cost of application derivative. Now we'll proceed for solving some numericals using this particular formulas. Now here it's given that if the total cost functions C is 3q cube minus 4q square plus 2q, that means here the output is q and the whole question will be treated in terms of q. Okay, so the total cost is given to you 3q cube minus 4q square plus 2q. Now what we have to do, find at which level of output, that means output means here find at which level, that means we have to find the q. We have to find the q here, where average cost be minimum and the level, and what level will it be. That means the question is demanding that at what value of q, that means at what level of output, that is output is here q, the average cost, that is AC, is minimum. We have to first find that, and also we have to find AC minimum value. So let us first of all find the average cost. From, as we know our cost as well as we know the output is q, so we can simply find our average cost. So solution part, given C equals to 3q cube minus 4q square plus 2q. This is given to you. So first of all, average cost is equals to total cost by output. That is total cost is 3q cube minus 4q square plus 2q. Output is here q, because the cost function is given in terms of q. So from there we get our output as in terms of q. So now dividing each term by q, so finally we will get AC equals to, first of all each term is divided by q, that is 3q square minus 4q plus 2. So this is our average cost. Name this as equals to 1. Okay, so we have found our average cost. Now what we have to show, we have to find the average cost minimum. We can do it very easily. That means here we can have to find the minimum value. So we know, suppose this is the function, this is your y, then you have to find the minimum. That means you have to find two things. First of all, first derivative and second order derivative. And for minimum value we have to equate equals to 0 the first derivative part. From there we will find out value and we will put that particular value in our second order derivative, and the sign will be positive, that will be declared as minimum. Clear? So let's start. First of all, find the first derivative. So now d dq, output is q, of average cost, that means derivative of this thing. Okay, that is d dq, average cost is 3q square minus 4q plus 2, that is d dq of, okay, q square derivative, remove directly, q square derivative 2q, that is 2 into 3 6q, q derivative 1, that is similar like as x derivative is 1, so this is 4. So this is our nothing but d dq of AC. Number 2. Now second order derivative, and now the second order derivative again d square by dq square of AC, that is second order derivative. Now q derivative is 1, so 1 into 6 6. Okay, so first of all write that d dq of, that is differentiating both side, 6q minus 4. Derivative of q is 1, so 1 into 6 6. Derivative of 4 is a constant derivative is 0. This is our second order derivative. Number 3. Now for minimum, you have to write here that for minimum we have to show minimum, so that for minimum what you are doing, equating the first derivative equals to 0, because you have to show that average cost be minimum, that's why we have equating the average cost derivative. Now average cost is here, d dq of average cost is 6q minus 4 equals to 0. Now from here if you simplify, you will get q equals to 2 by 3. 4 will goes to that side, divided by, so this is q by 3. Now we are going to put q equals to 2 by 3 in our second order derivative. Putting q equals to 2 by 3 in expression number 3. So that is d2 by dq2 of AC. Now what was our second order derivative? 6. There was no q, so there is no place of putting q equals to 2 by 3, so it will remain as 6. And if this is positive, that is greater than 0, and positive means minimum. So therefore average cost is minimum at the level of output, at the level of output q equals to 2 by 3, and its minimum value is that means average cost minimum. So what was the average cost function? This is average cost function. In terms of q, you have to put 2 by 3, that is 2 by 3 whole square minus 4 into 2 by 3 plus 2. So that is, after simplifying, you will get 4 by 3 minus 8 by 3 plus 2, that is minus 4 by 3 plus 2, that is 2 by 3, the answer. Okay, so this is all about, just check the calculation part. So in this way we have shown the average cost is minimum. Okay, just the application of derivative, that means the uses of differentiation formulas, the uses of concept of maximum minimum, that all comes in this topic. So this is all about the question 1. Now let us proceed to the next question. Okay, so the question number 2 is a lengthy question. So see that a radio manufacturer produce X set per week at a total cost of rupees x square by 25 plus 3x plus 100. That means your total cost is given to you x square by 25 plus 3x plus 100. That means first of all we write C is here x square by 25 plus 3x plus 100. Now C is in terms of X, that means here the output is X. Okay. Now last, he is, that means the radio manufacturer is a monopolist, and the demand for his market is X is given to you 75 minus 3p. The demand, that is X equals to, now if you remember the demand we have studied in which part? The revenue part, the quantity demand Q. But here what is demand is given to you? X. So that means the demand or the X, where P is the price in rupees per set. P is denoted as the price. Show that the maximum net revenue, what we have to show? Net revenue. Show that the maximum net revenue is obtained when above 30 sets are produced per week. That means the maximum revenue will occur when above 30 sets are produced per weeks. That means when, okay, we will discuss about later on this part because this is solution part. After solving you will get to know. So what we have to show, we have to find the maximum net revenue. Just remember this thing, maximum net revenue. Okay, so the solution part. Now net revenue that is denoted by NR. The formula is total revenue minus total cost. Okay, now total revenue is price into quantity. Price into quantity, that is P into quantity is here, that is demand. Quantity demand is here X, because in the question is given the demand, and demand for the market is X. X minus total cost is given to you X square plus 25 plus 3X plus 100. Remember one thing I will always say that if your total cost is in the variable of X, then whole the problem will be solved in terms of X. If it is in terms of Q, then whole the question will solve in terms of Q. Remember this. So that means we have to convert this full function in terms of X. Now this side is NR. Now this side X, this all term bracket term is also X, but here is the P. So we have to find this P value in terms of X only. So from where we will get? From there, this expression, that is X equals to 75 minus 3P. So from here we can find our P in terms of X and we'll put it here. That means from here if you find P, just shifting them, 3P equals to 75 minus X, just side changing. So finally what is your P? P equals to 75 minus X by 3. Now putting that P value, that is net revenue equals to 75 minus X by 3, that is P into X, and this said X square plus 25 plus 3X plus 100. Now further simplifying, that means just multiplying them, we will get. So now we'll multiply by X, that is 75X, and divide each term by 3, that is 75X by 3 minus X square by 3. Just simply multiplying 75X by 3 minus X square by 3, and minus this bracket part, X square by 25 plus 3X plus 100, similarly this bracket. Now opening the bracket, now 75 by 3, if you divide, you will get here 25. 25x minus x square by 3. Now just opening the bracket, minus x square by 25 minus 3x minus 100. Now 25x minus 3x, that is 22x. Now adding these two terms, that is x square by 3 minus x square by 25. If you add them, you will get 28x square by 75 and then minus 100. So this is all about your net revenue function. Now what we have to find? We have to find maximum net revenue. That means again we have to find the maximum value of this. So for that we have to differentiate, and second order differentiate of net revenue we have to find. So let's do that. ddx of net revenue, that is ddx of 22x minus 28x square by 75. Okay, so ddx of net revenue, that is ddx of this function. Now 22x, x derivative is 1, so 22 minus x square derivative is 2x, and 100 is a constant part and constant derivative is 0. So this is ddx of nr. Now again, second order derivative, that is ddx of 22 minus 28 into 2 by 75 x. Now 22 is a constant, 0, similarly like minus. Now here x derivative is 1, so 28 into 2, that is 56 by 75. Okay, so this is second order derivative. Now for maximum value we have to equate first order derivative equals to 0. So let's do that. For max value, for maximum, ddx of nr equals to 0. That is 22 minus 28 by 75 into 2x equals to 0. That means 22 equals to 28 into 75 into 2x, taking minus part to that side. Now 2 and 22, that means cancelling gives 11. Now finally what will be our x? Just do the cross multiply. 75 goes to in the numerator and 28 will goes in denominator, that is 11 into 75 by 28. Now using the calculator you will find x equals to 29.464. After using the calculator part you will get the calculation as 29.464. Now what I will write here, if you remember the question says that show that the maximum net revenue is obtained when above 30 sets are produced per week. And set at the first line of the question, a radio manufacturer produce x set. That means x set, the set is denoted by x. And at the end the question says that show that the maximum net revenue is obtained when above 30 set are produced per week. That means the x value, when maximum net revenue will occur when the x value is above 30. The meaning of that line, that show that maximum net revenue is obtained when above 30 sets are produced. That means whenever the value of x is greater than, that is above 30, then only the maximum net revenue is obtained. That means the minimum benchmarked for x value will be 30, because 30 and above, for that particular values of x, maximum net revenue is obtained. So here the x value is 29.464, so we will directly write 30 approx. Okay, so the x value is 30. And next what we have to find, so we have find the level of output, that means at which level the maximum net revenue will occur. This is one part. And the another part was the last part, what is the monopoly price? That means you have to find the price. Now if you remember, there is only one relation in this question regarding price and output. So that relation is x p equals to 75 minus x by 3. If you remember this relation, that is p equals to 75 minus x by 3. So we have to find the monopoly price. So what was the x? X is about 30, just put it here. 75 minus 30 by 3, that is 45 by 3, that is 15. So the price is 15. So this question is very important. Just you have to understand what the question wants to show, or what the question wants to prove, then everything is simple to you. Just because once you create that main function, that the procedure, that net revenue, whatever the question demands, then after that is calculation part, that is doing the first derivative, second derivative, these all are familiar to you. So now let's proceed to the question number 3. Okay, question number 3 says that a manufacturer can sell X items per month at a price P equals to 300 minus 2X. That means price is P, X is your, you can say, the output or demand. In case of revenue, it will treat it as demand. In case of cost, it will treat it as output. Produce item cost the manufacturer Y rupees, where Y equals to 2X plus 100. 2X plus 1000. Now see, produced item cost, that means this is nothing but your cost is given, just the notation has been changed from C to Y here. Just instead of C they are using Y, but here the cost is, that means your total cost is given 2X plus 1000. How much produce will yields maximum profit? Now remember, how much production will yields maximum, what we have to find? Profit. So now the profit formula is, I will just give the hint, you have to solve. Profit formula is same, that is your net revenue. Total revenue minus total cost. Revenue is price into quantity. Total cost given to you 2X plus 100. Profit we will denote it as P, capital P, not small p. These are two different. This is small p, price means small p, profit means capital P. Okay, so capital P equals to what? Now price is given in the question part. What is given to you? Price 300 minus 2X into X, and here this is in the bracket 2X plus 100. Now let us simply simplify. After that you will simplify this one, and now what we have to show, you have to find the maximum profit. What we have to find, you have to find the maximum profit. That means first of all you will differentiate P, then again second order derivative P, that means you have to find dP by dx, then you have to find d2P by dx2. These two things you have to find. Now for maximum value, what we have to do, we have to equate dP by dx equals to 0. From there we will going to find the value of x. Okay, now one thing about the value of x, I will say here that while solving this part you will get x equals to 74.5. This value you will get x equals to 74.5. Now what x indicates here? X indicates that sale items per month. Per month, that means it represents the months, and it cannot be in a fraction part. That means it cannot be in a fraction part, and this is the maximum. Not number cannot exceed 74.5, because this gives the maximum. For this x equals to 74.5, you will get a maximum value. Okay, so this is will your maximum output. So number cannot, the x cannot exceed 74.5, and it cannot be also in the fraction because it represents the month. So you will write x equals to 74, as it cannot be fraction and it cannot exceed 74.5. So it will be 74. So the x value we will get here 74. Now after putting x equals to 74 in your second derivative, you will get your negative, and that it indicates the maximum. Clear? So this is your homework for you. Just try this one. Simple question. Let us go for the next question. Okay, so question number 4. For a certain establishment, the total revenue function R and the total cost function are given by R equals to 83x minus 4x square minus 21, and C equals to x cube minus 12x square plus 48x plus 11, where x is output. Obtain the output for which the profit is maximum. Again the profit, that means again the profit means you have to find profit. Use the formula profit equals to total revenue minus total cost. And now total revenue what is given to you are, that is 83x minus 4x square minus 21 bracket minus total cost in bracket. What is total cost given to you? X cube minus 12x square plus 48x plus 11. So this is the profit is given to you. Now again you have to find a maximum profit. Now you know how to find. This is a homework for you. Try this one. Simply find first derivative, then second derivative. Equate first derivative equals to 0. From there you will get the value of x. That will be your output. Now put that output in your second order derivative. You will get a negative. That because you have to show maximum, and that is the required answer. That means here you have to find x. Okay, so this is all about the question number 4. Now let us start with question number 5. Okay, question number 5. Let me question. The total cost function of a firm is C. So C is given to you. First of all, let's say what are the given parts. X cube by 3 minus 5x square plus 28x plus 10. Okay, so from the first line we get the total cost function of a firm is C, where C is the total cost and X is the output. Okay, we get that. Now the next line, very careful about this particular line. A tax at a rate of rupees 2 per unit of output is imposed. That means a tax of at a rate of rupees how much? 2 per unit of output. That means 2 rupees on which? On the output, that is 2 into x. Finally 2x is imposed. Imposed means is added. And the producer adds it to his cost. That means that tax, this is the tax 2x, and that tax is added to the cost. That means this was the cost given to you. Now the tax, after adding the tax, so finally what the cost you get? This is the cost function you get. X cube by 3 minus 5x square plus 28x plus 10 plus 2x. 2x is the tax added to the cost. That means 28 plus 2 you can simply write 30x. So this is the C. Okay. Now, if the market demand function is given by P equals to 2530 minus 5x, where P is the price per unit of output. So what is given to you? P is given to you 2530 minus 5x. Okay. This is also given to you. Now what we have to find? Find the profit. Again the profit maximizing output. That means we have to find from here. First of all, we have to profit. Profit means again total revenue minus total cost. Now total revenue is price into demand minus total cost given to you x cube by 3 minus 5x square plus 30x plus 10. Now P, what is the P given to you in the question? 2530 minus 5x into x minus this total same part. Now after multiplying, that means multiply by x, and then this will be your P. So you will get your P from here. So now what we have to find? This will be your required P. Now from that we have to find maximization. Now maximization means, that means you have to find again dp by dx, then d2p by dx2. These two things you have to find. Now for maximum value, what we have to do? You have to equate dp by dx equals to 0. From there you will get a value of x. From there you will get the value of x. Now I'm saying after equating dp by dx equals to 0, you will get x equals to, I'm just giving the answer, x equals to 50. Remember, after equating dp by dx equals to 0, you will get x equals to 50. That is the demand of the question. That what you have to find. Find the profit maximizing output. That means you have to find this x. So the x value will be 50. Okay. And and last line price. That means you have to find the maximum price also. So how to find that? If you remember that the p is given in the question, that is 2530 minus 5x. You have to find the maximum price. So what is the output you get? X equals to 50. Simply put it here. That means price equals to 2530 minus 5 into 50. After simplifying, you will get 2280 as the price. So these are the answer. The output you will get x equals to 50 and the price you will get 2280. Cost is given to you, but a tax that is 2x is added to this cost function. So after adding with this 2x, you will get the cost this. Just simply adding 28 plus 2x. So this is the cost. Now you have to find the profit. Profit means total revenue minus total cost. Total revenue means price into demand, that is P into X. Price is given to you. Just putting the price into X. Now just simplify and differentiate. Simple. Okay, so this is our question number 5. This is also homework for you. So consecutive 3 questions I given homework for you. More homeworks are there. This is one of the easiest question in your textbook. The total cost is for the output X is given to you. C equals to 3x by 5 plus 15 by 4. First, what we have to find? Cost when output is 5. That means for first, we have to find the value of C by putting x equals to 5. That means in place of x, you will put 5 and you will have to find the cost. Finish. Number 2, you have to find average cost of output of 10 units. That means first of all, you have to find the average cost. That is total cost by output. You have to find that. And after that, by putting x equals to, what is that? Here 10. You have to find the value of average cost. Clear? And the third one is marginal cost, and marginal cost equals to the derivative of total cost. What is total cost? Total cost is this. Clear? Very simple question. Now question number 7. So the average question number 7, the average cost function AC for a certain commodity is given to you. AC equals to 2x minus 1 plus 50 by x in terms of output x. So the average cost is given to you. Okay, now the first part of the question is find the output for which average cost AC is increasing and decreasing with increasing output. So first of all, the first thing is I have to say increasing. A function or is said to be increasing if its first derivative, here the first derivative you have to find of average cost, so I will say for that only. So increasing means the first derivative will be greater than 0, and decreasing means the first derivative will be less than 0. Just remember that. Increasing means the first derivative will be greater than 0. Decreasing means the first derivative is less than 0. So find the output for which average cost is increasing and decreasing. We have to find the output. That means we have to find the value of x basically. Now the last 3 words, that comma with increasing output. Now this line means, now while finding the output of x, we will get 2 values. I'm saying we will get 2 values, 5 and minus 5. You will get these 2 values of x. But what it say? With increasing output mean with increasing output. That means out of this 2 value, we have to take the increasing one. Now which is the increasing one? That means which is the greater one? We can simply see that 5. So we will ignore this minus 5 and we will deal for x equals to 5 only. Okay, and next we have to find the total cost and the marginal cost. So let's proceed for the solution part. This is the average cost given to you. So for the first one, we have to find the first of all the first derivative, because as well as for increasing and decreasing we have to find the first derivative. So let us do that. So here d dx of average cost, that is d dx of 2x minus 1 plus 50 by x. Now 2x, x derivative is 1, so 2. Minus 1 is a constant derivative is 0. Okay, 0. And here 1 by x. 1 by x derivative is minus 1 by x square. So that is minus 1 by x square. And 50 was the constant. So this is your d dx of average cost. We got this. Okay. Now first of all, for increasing. For increasing, what we get? D dx of average cost will be greater than 0. That means what is d dx of average cost? We get 2 minus 50 by x square greater than 0. That means 2. Now let us take this minus part to that side, that is greater than 50 by x square. Now just do the cross multiplication. There is 2x square. Just shifting x square to that side is greater than 50. Now let us guess 2 with 50, that is 25. So what gives x square is greater than 25. Now removing the squaring, there is shifting the square to that side, or what we can say 25 as 5 square. We can write 25 as 5 square. Now cancelling the square, what will get? X greater than 5. Clear what we have done? See again. First of all, the first derivative of average cost greater than 0. Now putting that value greater than 0, not taking the minus part to that side, that is 2 greater than 50 by x square. Now taking x square cross multiplication, then it from denominator it will goes to numerator. 2x square greater than 50. Now 2 cancel 50 gives 25. Now x square greater than 25. Now here the two values are coming, 5 and minus 5. That's why I'm saying we will just take the increasing output. So that's why I've just taken the 5, not the minus 5. Basically what we are doing, if I'm writing an equation x square equals to 25, then x has two values. One is 5, another is minus 5. But here what say? The increasing output. That means we have to neglect the minus part, that is the lowest part. So here 25 can be written as 5 square. Now cancelling both sides square, x is greater than 5. This is for the increasing part. Clear? Now similarly same thing for decreasing part. For decreasing part, d dx of average cost will be less than 0. Now putting that value, 2 minus 50 by x square less than 0, that is shifting to that side, 2 less than 50 by x square. Now shifting side change, 2x square less than 50, cancelling it becomes 25, that is x square less than 25, that is the value of x is less than 5. So for decreasing. Okay, so the first part finish. Okay, now the second part asks for total cost and marginal cost. Okay, so the total cost. So we know that the average cost formula is total cost by output. What is the output? X. This is the formula. So from here what we have to find? We have to find the total cost. That means total cost equals to average cost into x by this particular formula. Just doing the cross multiplication. Now what is average cost? 2x minus 1 plus 50 by x into x. Just multiply it. There is 2x square minus x, minus 1 into x, and after multiplying this you will get here 50. So total cost is 2x square minus x plus 50. Next what we have to find? Marginal cost. So we have find the total cost. Now for finding average cost, we know average cost is d dx of total cost, that is derivative of total cost. After differentiating you will get 4x minus 1. So this is all about the question number 7. Now let us proceed to the question number 8. Okay, the question number 8 is that let c equals to 3x into x plus 7 by x plus 5 plus 4 be the total cost of x units of output for a product. Show that the marginal cost falls continuously as the output increases. This line. You have to prove that, show that the marginal cost falls continuously as the output increases. Now, that means the question is regarding the marginal cost. That means we have to find the marginal cost. The first thing is clear from this part. So what is the C total cost given to us? 3x, x plus 7 plus x plus 5 plus 4. So let us multiply this thing. So we get x plus 5, 3x into x, that is 3x square, plus 7 into 3x, that is 21x, plus 4. So this is our C. Okay. Now we have to find the marginal cost. That is, marginal cost equals to derivative of total cost. That is d by dx of 3x square plus 21x by x plus 5 plus 4. Now 4 is a constant part and we know that constant derivative is 0. So this part will vanish. Now for this particular part, that is this bracket part, you can see that division. So we have to use a division rule. So the task of your is that you will simply differentiate this thing. And after differentiating all this, you will get, I'm just writing the final outcome. That means after differentiating, because this thing we have done multiple of times, that means division rule like that. So this is the homework for you, just simply differentiate. And after differentiating, you will get in this particular form. You have to convert in this particular form after differentiating. That is marginal cost, you will get 3 plus 30 divided by x plus 5 whole square. Okay. So now from this, the conclusion. What was the conclusion? Shows that as the output means your x increases, the marginal cost falls. Falls means decreases. That means as x increases, marginal cost decreases. Now see how. X is in denominator. Now if we increase the denominator, it is quite natural that this total value will decrease. If it going to increase the x, that which is in the denominator, it is quite natural that this full value is decrease. Because if I say 30 by 10 and 30 by 20, if I am increasing the value, see 30 by 30 and 30 by 40, see I am increasing the value. So that means the value decreases, start decreasing. 30 by 30 is 1, 30 by 40 is less than 1, 30 by 50 is more less than. So like that, if we increase the denominator, the full fraction will decrease. So that will say that the marginal cost will decrease. So whenever the value of x increase, the marginal cost will falls continuously. So you will write after that, after proving this thing, you will write here output x unit is in the denominator. Is in the denominator. So as x increases, marginal cost falls or decreases continuously. Clear? As the output x unit is in the denominator, so as x increases, marginal cost decreases. But before that, you have to differentiate this and you have to convert in this particular form. I hope you can do that. So this is all about question number 8. This question comes in NBO in 2006. Very long year ago. So this is all about the question number 8. Now let us proceed to the question number 9. Okay, so the question number 9, the cost function for commodity Q is given as, the cost function is provided to you. C equals to Q cube minus 4Q square plus 6Q. Find the average cost, that is you can do total cost divided by output Q. Okay, so the first part finish. And also find the value of Q, that means you have to find the value of Q for which average cost is minimum. That means same ditto question number 1. That means average cost minimum, that means you have to find your average cost. Now you have to, for the minimum, you have to find ddq ddq of average cost. Next, d2 by dq2 of average cost. These two things you have to find. Then for finding the value of q, you have to equate ddq of ddq of AC equals to 0. From there you will find the value of q, and that thing we have required. Clear? Question number 9. This is similar like a question number 1, the first question of today. Okay, so now let's put to the last question, question number 10. Okay, question number 10. C equals to, that means total cost given to you, 0.03 q cube plus 0.5 q square minus 12q plus 2. Very simple. Now first, what we have to find? Average cost. We know that average cost equals to total cost divided by, what is the output here? Q. You can find that. That means dividing each term by q. Okay. Now next, average AVC, that means average variable cost. If you remember that different form of cost function we have discussed, there we have discussed the average variable cost. See, if you focus in the cost here, there is a function of q plus a constant k. That means if it's saying c equals to f of x plus k. So the average variable cost will be here. If you remember there, average variable cost, we have denoted this formula f of x by output, where your c was f of x plus k. Similarly here, instead of x, there is a q. So the average variable cost will be just your function 0.5 q square minus 12q divided by q, ignoring the constant part. This is your average variable cost. If your cost is f of x plus k, the average variable cost is just the function divided by the output, just ignoring the constant part. Now marginal cost. Now marginal cost we know very easy, that is ddq. Q means why q? Because their output is q. ddq of total cost. ddq of total cost. So after differentiating, you will get here, I'm just writing the value. After differentiating, you will get 0.09. Just you will check the answer, plus q minus 12. Okay. After differentiating, that is marginal cost equals to derivative of total cost. You have to differentiate this part. Q derivative is 3q square. That means 3 into 0.03 is 0.09 q square. Q square derivative is 2q. 2 into 0.5 is 1. So I'm just writing here q. Minus 12q. Q derivative is 1. So 12. So this is the derivative of total cost. That is your marginal cost. Now the next one, slope of average cost. Now slope. In the chapter of derivative, we have said slope means derivative dy by dx. Remember, so slope of average cost is nothing but differentiating your average cost with respect to the output. What is the output here? Q. That is, whatever the average cost you will get from 1, just put it here and find their differentiation. Slope of average cost means differentiation of average cost with respect to the output, and here the output is your Q. That means differentiating AC with respect to output, of average cost. So the average cost we will get from 1, just put it here, you will get your answer. And finally the last one, slope of marginal cost. Same, differentiating the marginal cost with respect to the output. What is the output here? Q. What was the marginal cost we get? 0.09 q square plus q minus 12. Now after differentiating, q square derivative is 2q. 2 into 0.09, that is 0.18 q. Q derivative is 1 and 12 is 0. So this is the slope of average marginal cost. Okay. So average cost, total cost by output, average variable cost means just
writing the Q part, ignoring the constant, and same divided by output. Marginal cost equals to derivative of total cost, that is C, with respect to the output, that is Q, that is d dq of C. After differentiation we will get this thing. Slope of means differentiation. Slope of AC means differentiation of AC, that is average cost with respect to the output. Output is here Q. And the last one, slope of marginal cost, that is differentiation of marginal cost with respect to output, that is Q. Okay, so these are the question from your application of derivative part. I have given total 5 homeworks, including this 6, including this question, to total 6 question as a homework. So there are some formula, there are some questions we have discussed in this video. I hope you will get to know about the application of derivative topic. If you have any doubt, any question, you may ask me later on. I will try to solve that also. And thank you for watching this video. Thank you very much. Goodbye.